Hello everyone and welcome back to the Intro Algebra video lectures. Today we are going to be starting the process of solving two-step linear equations. So in these equations, they require two steps to solve them because there are two different operations that are being done to the variable. And each of these operations must be undone one at a time. Now, the overall idea is the same as solving one-step linear equations. You need to do the opposite operations than the ones that are being performed on the variable. The tricky part is knowing the order in which to do the steps. You guys are used to simplifying expressions in which there is a very specific order that operations must be done. Now, in solving equations, when you are undoing those operations, what you're essentially doing is order of operations backwards because you're undoing the mathematical operations to move them to the other side of the equal sign. So it's that order of operations that you are well accustomed to done in reverse. So the first thing that you're going to do is you're going to undo any adding or subtracting first. So first you will add or subtract any constant terms that do not have a variable, and you're going to move them to the other side of the equal sign. Then after that, the second thing you do is you undo any multiplication or division. So you're going to multiply or divide, undo any multiplication or division, and remember, if the coefficient is a fraction, you're going to multiply both sides by the reciprocal. So that's the general gist of solving two-step equations when there are two different operations being performed on your variable. The first thing that you undo is the adding or subtracting, and then you're going to undo the multiplying and dividing. It's basically order of operations backwards. So together we are going to solve this equation. And the reason that this is a two-step equation is because there are two different operations that are being performed on the variable. The variable is being multiplied by 3 and we are adding 1. And just like with one-step linear equations, you do not ever want to move the equal sign. The equal sign is an immovable fence, and you cannot ever move the equal sign. So you should be able to draw a mostly vertical line down all of your equal signs. And another thing to remember is the golden rule of algebra. Whatever you do to one side, you must do the exact same thing to the other. So the first thing that I'm going to do is I'm going to undo this plus 1. This 1 has no variable on it, so this is what is called a constant term. So the first thing that I'm going to do is I'm going to undo this addition by subtracting 1, and then whatever you do to one side, you must do the exact same thing to the other. Now on the left, 1 minus 1 is 0 and cancels out. Remember, the equal sign has not moved. Now, even when those cancel out, you still have this 3x left over, so I'm going to carry down this 3x. And then on the right-hand side, I'm going to combine these two like terms. 10 minus 1 is equal to 9. Now that the addition has been undone, next I'm going to undo this multiplication. So since the 3 is being multiplied by x, the opposite of multiplication is division. So then I'm going to divide this by 3, and then whatever you do to one side, you need to do to the other. On the left, 3 divided by 3 is 1 and cancels out because 1 times x is just x. So x is now by itself. Equals 9 divided by 3 is 3. So now x equals 3 is your final answer. And remember, if you ever wanted to check your answer, all you would have to do is plug your answer 3 into the original equation in place of your x, follow order of operations to simplify it, and see if you get the same number on each side of the equal sign. So I want you guys to try that for yourself. I want you to take the equation 5x minus 2 is equal to negative 12, and I want you guys to solve for the variable x using those steps that I just outlined in the previous example. So go ahead and pause the video and then resume when you are ready to check your answers. Okay, so once again, you don't have to do this with the line down the equal signs. It's just something that I like to do to make sure that the equal sign never moves and that you're keeping the equal sign in the exact same spot. So the side that you start with is the side with the variable. The variable is over here on the left, so I'm going to focus on the left side here. Now the variable is being multiplied by 5, and we are subtracting 2. This 2 does not have a variable, so it is called a constant term. So the first thing that I'm going to do is I'm going to undo this subtraction. The opposite of subtraction is addition. So I'm going to get rid of this minus 2 by adding 2 to both sides. On the left, negative 2 plus 2 is 0 and cancels out, leaving you with 5x. Leave the equal sign where it is, and then on the right, negative 12 plus 2 is going to give you negative 10. Next, I'm going to undo this multiplication using division. So I'm going to divide both sides by 5, because remember, whatever you do to one side, you need to do to the other. 5 divided by 5 cancels out. 1 times x is just x, equals negative 10 divided by positive 5 is negative 2. So x equals negative 2 is then your final answer. And I will say that the easiest way to master this is to just do a whole bunch of practice problems. So I'm going to go through at least a few of these, and then I'll give you another chance to try any. But remember, if at any point that you want to try a problem before I do it, even if I don't give that opportunity in the video, just pause the video and then resume when you're done if you want to check your answer. So the next thing I'm going to solve is this 2n plus 5 is equal to 15. Again, I'm not going to move the equal signs. On the side with the variable, I have addition and multiplication. So because we are doing order of operations essentially backwards, I'm going to start by undoing this plus 5. So to do that, I am going to subtract 5 from both sides of the equation. 5 minus 5 is 0 and cancels out, leaving you with 2n. And then on the right, 15 minus 5 is 10. Then to finish up, I'm going to undo this multiplication using division. So I'm going to then divide both sides by 2. 2 divided by 2 cancels out, leaving you with n equals 10 divided by 2 is 5. So n equals 5 is then your final answer. Looking at this next one right below it, I have this 1/2 times w plus 3 is equal to 10. So the first thing that I'm going to undo is the plus 3. I'm going to undo that plus 3 by subtracting 3 from both sides of the equal sign. On the left, 3 minus 3 cancels out, leaving you with 1/2 w equals 10 minus 3 is 7. Now this one's a little bit different because remember, our coefficient here is a fraction, and dividing by a half is the same as multiplying by its reciprocal. So instead of dividing by a half, I'm going to save myself some work, and I'm going to do the keep, change, flip right away. So because my coefficient is a fraction, I am going to take both sides, and I'm going to multiply both sides by the reciprocal. The reciprocal of 1/2 is 2 over 1, or just 2. Whatever you do to one side, you need to do to the other. Now 1/2 times 2 cancels out because any number times its reciprocal is 1, leaving you with w equals 7 times 2 is 14. So w equals 14 is then your final answer. Looking at this next one here on the top right, I have x over 3 minus 4 is equal to 1. An alternative way of reading this x over 3 is x divided by 3 minus 4 is equal to 1. So on the side with the variable, we have two operations. We have subtraction and then we have division. So because we're essentially doing order of operations in reverse, I'm going to get rid of this minus 4 first by adding 4 to both sides. Whatever you do to one side, you need to do to the other. So then on the left, negative 4 plus 4 cancels each other out, leaving you with x over 3 is equal to 1 plus 4 is 5. Then I'm going to undo this division. Now the opposite of division is multiplication. So the opposite of dividing by 3 is multiplying by 3. So I'm going to get rid of this divided by 3 by multiplying both sides by 3. On the left, 3 over 3 cancels out, leaving you with x equals 5 times 3 is 15, and x equals 15 is then your final answer. And then for this last one, it's going to be the same idea. On the side with the variable, we have subtraction and multiplication. So the first thing that I'm going to undo is that subtraction. The opposite of subtraction is addition. So I'm going to start by adding 9 to both sides. Negative 9 plus 9 cancels each other out, leaving you with 6y equals 3 plus 9 is 12. Then I'm going to finish up by undoing this times 6 by dividing both sides by 6. And then for my final answer, I'm going to get y equals 2. So that is going to be the same general idea for each of these. Now remember, the only thing that you want being multiplied on your variable in the end is a hidden positive 1. So if your x is being multiplied by a negative, you will have to divide by a negative at the end. So I want you guys to try these three, solve for the indicated variable, pause the video, and then to work through these three, and then resume when you are done working. Okay, so looking at this next one, for 3x plus 4 is equal to 7. So the first thing that I'm going to undo is this plus 4 by subtracting 4 from both sides. 4 minus 4 is 0, leaving you with 3x here on the left, equals 7 minus 4 is 3. Then I'm going to undo this multiplication by dividing both sides by 3. 3 divided by 3 cancels out, leaving you with x is equal to 3 divided by 3 is 1. So yes, while these two effectively cancel out, remember they don't go away when they cancel out. They become 1. 1 times x is just x, and then equals 3 divided by 3 is equal to 1. So x equals 1 is your final answer. Now for this next one over here on the top right, we have r divided by 2 plus 5 is equal to 9. So the first thing that I'm going to do is I'm going to subtract 5 from both sides. 5 minus 5 is 0 and cancels out, leaving you with r divided by 2 is equal to 9 minus 5 is 4. Then I'm going to finish getting r by itself by multiplying both sides by 2, because the opposite of dividing by 2 is multiplying by 2. 2 over 2 cancels out. 1 times r is just r, equals 4 times 2 is 8. So r equals 8 is your final answer. And then we're going to do the same basic thing for this last one. So for this last one, there is multiplication between the negative 4 and the x. So negative 4 is being multiplied by x, and then we are adding 7. So the first thing that I'm going to do is I am going to subtract 7 from both sides. 7 minus 7 cancels out, leaving you with a negative 4x here on the left, equals, and then on the right we have 3 minus 7, which is negative 4. Now remember, the only thing you want being multiplied on your variable in the end is a positive 1. So I'm going to get rid of this multiplication by negative 4 by dividing both sides by negative 4. On the left, negative 4 divided by negative 4 is 1. 1 times x is x, equals, on the right, negative 4 divided by negative 4 is positive 1. So x equals positive 1 is then your final answer. Now, this next group is a little bit trickier because you have to remember that you are adding or subtracting the constant first. So the addition or subtraction that you are undoing is effectively moving any terms that do not have variables onto the other side of the equal sign. And this can be trickier, especially when you have negatives and subtraction, and especially when the variable is not listed first, because the variable does not need to be the first term listed. In fact, and oftentimes it's not. So I'm going to do this next group with you. So for this first one, we have negative 7 minus 3x is equal to 0. You have to keep in mind that division should be the last thing that you do, that a number always takes the sign to its left, and you have to undo multiplication last. So let's take a look at the variable and figure out what exactly is being multiplied by our variable. So what is being multiplied by this x? This 3 is technically negative. So this negative 3 times x is all its own term. And our very last step is going to be dividing both sides by negative 3. Now that leaves this minus 7 over here that does not have a variable attached to it. Because there's no variable attached to it, this is considered a constant term, and that needs to be moved to the other side first. So the first thing that I'm going to do is I'm going to move this minus 7 over to the other side. Now the opposite of a negative is a positive. So I'm going to move this negative 7 over to the other side by adding 7 to both sides, because you need to do the opposite. The opposite of a negative is a positive. So then on the left, negative 7 plus 7 is 0, which leaves you with negative 3x equals, and then 0 plus 7 is 7. Then you're going to undo this multiplication using division. So I'm going to divide both sides by negative 3. Now I kind of ran out of room, so I'm going to put my answer up over here. So you're left with x is equal to 7 divided by negative 3. Yes, it is a decimal, and you're not going to input a decimal as your answer. You can and will often get a fraction for a final answer. So it is okay if you leave your answer as negative 7 over 3. Yes, you can leave it as a fraction, and yes, I highly encourage you to leave it as a fraction. And if it's an improper fraction, you do not need to turn it into a mixed number. In fact, please don't turn it into a mixed number. Just leave it as negative 7 over 3. And that's a good enough final answer. I'm going to do the one below it next. And remember, the variable also does not need to be on the left side of the equal sign. You always start with the side that has your variable. So the side that has my variable is the right side. So because my variable is over here on the right, I'm going to focus on the operations that are on the right side of the equal sign. So let's first start with what is x being multiplied by. X has a 2 next to it, but since a number always takes the sign to its left, this 2 is technically negative. So x is being multiplied by negative 2. And undoing multiplication should be the last thing that you do. So our last step is going to be dividing both sides by negative 2. Now that leaves us with this 9. This 9 does not have any variables attached to it, so it is considered a constant term. So we need to get rid of it first. Now, is this 9 negative or positive? If you look to its immediate left, there is nothing here. So when there is nothing there, the number is technically positive. So the opposite of a positive is a negative. So I'm going to move this 9 by subtracting 9 from both sides because the opposite of a positive is a negative. So then on the right, 9 minus 9 is 0, leaving you with negative 2x. And then on the left, 5 minus 9 is negative 4. Then you're going to undo this multiplication by dividing both sides by negative 2. Negative 2 divided by negative 2 is 1, leaving you with 1x equals negative 4 divided by negative 2 is positive 2. So x equals 2 is your final answer. Now for this next one here on the top right, it's going to be the same idea. You always start with the side that has the variable. So since the variable is here on the right, I'm going to focus on what's on the right-hand side. So x is being multiplied by a positive 3, and we know it's positive because there's nothing to its immediate left. So those are going to stay together for now, and I'll eventually undo that multiplication. Then that leaves this minus 7 that does not have a variable. So the opposite of minus 7 is adding, so I'm going to add 7 to both sides. Negative 7 plus 7 is 0, leaving you with 3x over here on the right. And then over here on the left, negative 5 plus 7 is positive 2. Then we're going to undo this multiplication by dividing both sides by 3. 3 over 3 is 1 and cancels out, leaving you with 1x equals, and you can leave this as 2/3. 2 divided by 3 is 2/3, so please leave it as 2/3. So x equals 2/3 is then your final answer. Don't freak out when you get a fraction for a final answer. It doesn't mean you did the problem incorrectly. Many equations have a solution that is a fraction, and sometimes it's not a pretty fraction. So for this next one, we have 5x plus 7 is equal to 10. The variable is here on the left, so I'm going to focus on what's over here on the left. The x is being multiplied by 5, and we are adding 7. So the first thing that I'm going to do is I'm going to undo this plus 7 by subtracting 7 from both sides. 7 minus 7 is 0, leaving you with 5x equals 10 minus 7 is 3. Then I'm going to undo this multiplication by dividing both sides by 5. And 3/5 is a fully reduced fraction. So you can go ahead and leave your answer as x equals 3/5. As long as your answer is fully reduced, you can leave your answer as a fraction, and you are going to have to leave your answer as a fraction on your homework. So x equals 3/5 is your final answer. You do not have to turn it into a decimal. So I want you guys to try each of these. So for each of these, the variable is not listed first. So the first thing that you should ask yourself is, what is being multiplied by the variable? What is the variable being multiplied by? And that is going to be your last step. And the first thing that you're going to do is you are going to move any constants that do not have a variable, keeping in mind that a number always takes the sign to its left. So I want you guys to try these next four, pause the video, and then resume the video when you are done working. All right, so for this next one, first thing I'm going to look for is I'm going to start with the side that has the variable, which is the left-hand side here. And I'm going to ask, okay, what is the variable being multiplied by? X is being multiplied by -4 because a number takes the sign to its left. So those two are going to stay together for now, and the last thing we're going to do is divide by -4. Which leaves us with this 1 over here, which does not have a variable. Since this is a constant term, it's going to move over to the other side first. Now, is this 1 negative or positive? Since there's nothing to its immediate left, this 1 is positive. So the opposite of a positive is a negative. So I'm going to get rid of this 1 by subtracting 1 from both sides. 1 minus 1 is 0, leaving you with -4x equals 5 minus 1 is 4. Then I'm going to finally undo this multiplication using division. So I'm going to divide both sides by -4. -4 divided by -4 is 1. 1 times x is just x, equals +4 divided by -4 is -1. So x equals -1 is your final answer. Then for this next one right below it, the x is on the left-hand side, so I'm going to focus on that side. And the first thing I'm going to figure out is what is being multiplied by my variable. So my variable is being multiplied by -5, since that 5 took the sign to its left. So those two are going to be attached for now, leaving us with this 6 that does not have a variable. I'm going to get rid of that first, and since there's nothing to the immediate left of this 6, that means this 6 is positive. The opposite of a positive is a negative. So I'm going to move this 6 over to the other side by subtracting 6 from both sides. So 6 minus 6 is 0, which cancels out, leaving you with -5x equals 1 minus 6 is -5. Then I'm going to finish up by undoing the multiplication and dividing both sides by -5. So on the left, -5 divided by -5 is 1. 1 times x is just x, equals, and then on the right, -5 divided by -5 is +1. So x equals +1 is your final answer. So then for the next one over here on the top right, I have 2 equals 11 plus 3x. So since the x is on the right side of the equal sign, I am going to start by focusing on the right side. So let's start with, what is my variable being multiplied by? My variable is being multiplied by a +3, since the 3 took the sign to its left. So my last step is going to be dividing both sides by -3. By dividing both sides by +3. That leaves us with this 11 that does not have a variable. And this 11 is positive since there's nothing to its immediate left. So the first thing that I'm going to do is I'm going to get rid of this +11 by subtracting 11 from both sides of the equal sign. So then over here on the right, 11 minus 11 is 0, leaving you with 3x. The equal sign does not move, so leave the equal sign where it is. And then 2 minus 11 is -9. Then I'm going to finish getting x by itself by dividing both sides by 3. 3 divided by 3 is 1. X equals -9 divided by 3 is -3. And if you don't like the way that's written, you can always switch them. So x equals -3 is your final answer. And then for the last one, we have 2 minus y is equal to 6. So I'm going to focus on the left side of the equal sign first. And then I'm first going to ask myself, what is my variable being multiplied by? Since there is nothing between the minus and the y, you can always assume that there is a 1 here. So the y is being multiplied by -1, so those two are going to stay together first. That means I'm going to get rid of this 2 that does not have a variable, and since this 2 is positive, I'm going to move it by subtracting 2 from both sides of the equal sign. So then 2 minus 2 is 0, which cancels out, leaving you with -1 times y is equal to 6 minus 2 is 4. Then I'm going to finish getting y by itself by dividing both sides by -1. So that leaves us with y equals 4 divided by -1 is -4. So y equals -4 is your final answer. I also apologize if you can hear a lawnmower in the background. I didn't realize that they were going to start doing this in the middle of recording, so I apologize if you can hear that in the background. Hopefully my voice is loud enough to drown it out. Anyways, so with fractions, if your coefficient is a fraction, it is easy to deal with because all you have to do is multiply both sides by the reciprocal, and it's not that big a deal, as we've seen in the last few examples. However, there are going to be some equations where everything is a fraction, where your x is being multiplied by a fraction, there's a fraction that's being added or subtracted, and there's another fraction on the other side of the equal sign. So equations with a whole ton of fractions like that can be very cumbersome to work with, and they can get very annoying, especially with the adding and subtracting, because you might remember that you need common denominators when you add or subtract fractions. So there is a way to work around this and make the equation a little bit easier to work with. And this process is called eliminating the fractions. So what you can do to eliminate the fractions and make your life easier is to multiply every single term on both sides of the equal sign by the lowest common denominator between all of the fractions. The golden rule of algebra is that whatever you do to one side, you need to do to the other. Now that applies to the entire side of the equal sign. So as long as you do the exact same thing to every single term on both sides of the equal sign, you can do almost anything you want. That includes multiplying by the lowest common denominator. Now the key is that the lowest common denominator needs to be the LCD between all of the fractions. It'll involve a little bit of cross-reducing and some multiplying by fractions, and you will notice that all of the numbers will get bigger, but all of the fractions will be eliminated. So what will happen is after the fractions are eliminated, you will be left with whole numbers, and then that'll allow you to solve the equation as normal without all of the fractions being so cumbersome. So this is an example of an equation where it would probably be a good idea to do this. So we have 1/2 x plus 1/5 is equal to 7/10. And yes, you can solve this by subtracting 1/5 from both sides and finding those common denominators, and then multiplying both sides by the reciprocal of 1/2. There's nothing wrong with that. But I'm going to show you how this little shortcut can make your life a little bit easier and eliminate the fractions so that you don't have to deal with them. Let's take a look at the three denominators first. We have 2, 5, and 10. What would be the lowest common denominator between all three of those? Well, 2 and 5 both go into 10, so this is an example where one denominator is a multiple of the other two. So the lowest common denominator between 2, 5, and 10 is going to be 10. So here's what I'm going to do. I'm going to take each of these terms, every single term on both sides of the equal sign, and I'm going to multiply all of them by 10. So this is what that will look like. I'm going to take 1/2 x and I'm going to multiply it by 10. Then I'm going to take the 1/5 and I'm going to multiply it by 10. I needed to give myself a little more room, so I had to push the equation over here. And then I'm going to take that 7/10 and I'm going to multiply it by 10. And then I'm going to take some time to do all of the cross reducing. So I'm going to take 10 and multiply it by 1/2. 2 and 10 have a common factor of 2, so 2 divided by 2 is 1, 10 divided by 2 is 5. And that leaves you with 5 times 1 is 5 over 1, which is just 5x. Plus, I'm going to do the same thing for the next term. So 10 and 5 have a common factor of 5, so 5 divided by 5 is 1, 10 divided by 5 is 2. 2 times 1 is 2, divided by 1 gives you just 2. And that equals, I'm going to do the same thing over here, and you might remember that when you have the same number on the top and the bottom, they cancel out to become 1. So 1 times 7 is 7, 7 divided by 1 is just 7. So what that did is, yes, it made all of the numbers bigger, but all of the numbers are now whole numbers. So what you can do is you can now solve this equation like normal without all of the cumbersome fractions. So I'm going to first get rid of this plus 2 by subtracting 2 from both sides. That gives me 5x is equal to 5. Then I'm going to get rid of this times 5 by dividing both sides by 5. And that gives me x equals positive 1. So x equals 1 would then be your final answer, and that was a whole lot easier to solve now that the fractions were eliminated. So that is just a suggestion, something that I highly suggest you do when everything involved in your equation is a fraction. So thank you all very much for watching this video. We are not quite done with section 8.3 yet. I'm going to split this into multiple videos because there is a lot of material in section 8.3, and I'm going to split it up by types of equations. So in the next video, we're going to get into equations that take more than 2 steps to solve. So stay tuned for that video. That'll be like a part 2 to this 8.3. I'm sorry if you can hear a lawnmower in the back of this video. I'm hoping that you can't really hear it. So thank you all very much for watching, and I will see you in the next video. Bye-bye.